Abhilash, please check Samir and Preeti. If they are in online, give a co-host to them. Other co-host, please admit to all. Divya, be ready.
Yes, sir.
Admin, please give the Google Talk link for a sharing of question. Vaishnavi, can we start the program?
Okay, sir. Okay.
You can call me as Sanna, no problem. They are all known persons only. Okay. Um,
Actually, if you are
very
in
good.
all.
Yes, yes. Very good afternoon to all. This is Dr. Wasim Alai, coordinator of this summer internship. I welcome you all for today's event of 1 month summer internship on recent advances in chemical sciences. Today's speaker is my friend and sister, Dr. Vaishnavi. She is working as assistant professor at the Department of Chemistry, CVG, Visalogy College for Women's, Vidumalpet, Tamil Nadu. With this introduction, now I hand over the session to Divya. Divya?
Yes, sir. Yes, sir. Am I audible, sir?
Yeah, you are audible.
Yes, sir. A warm good evening to one and all present here. I welcome you all for today's session of 1 month summer internship on recent advances in chemical science. Science, do you think it is a poetry of fantasy and incredible stories? No, it is a beautiful poetry of reality. This pandemic situation has unfortunately made everyone to stay at home, but learning science, expanding our knowledge and exploring different career options also becomes inevitable. We must always look for opportunity to learn and grow. And for the past 8 days, we are successfully utilizing the online platform effectively to provide a exceptional virtual experience of learning to the participant through this challenging period. And today, it marks our ninth day of summer internship. With this note, on behalf of Crescent family, I am extremely delighted to welcome the renowned and elegant speaker, Dr. E. Vaishnavi, for today's session. I thank her for providing her gracious presence to join us today to enrich our knowledge. Now, I extend my hearty welcome to Dr. S. Kutirani, Professor and Dean of School of Physical and Chemical Sciences, who make persistent efforts for delivering the best for us. And I also extend my hearty welcome to Dr. D. Ishwaramurthy, Head of Department of Chemistry, who continuously inspire us and make us walk towards the route of success. And I am pleased to welcome Dr. N. Vasimalai, Assistant Professor, the coordinator of this big event, without whom this online journey of enriching knowledge with eminent speakers would not be definitely possible. I also welcome the fellow participants for making their constant participation towards this program. Now, I would like to take this moment to introduce the speaker and highlight her distinguished works in chemistry. Dr. E. Vaishnavi qualified a PhD degree in chemistry from Bharatidasan University of Tiruchirappalli. She has 4 years of research experience in the field of nanochemistry, photochemistry, solar energy conversion, cadmium tellurium quantum dots to probe certain biomolecules and binding interaction with proteins and DNA. She was awarded UGC BSR JRF Meritorious Fellowship in Science from 2011 to 2013 and SRF position from 2013 to 2014. She has versatile ability in handling various instruments such as UV visible spectrophotometer, spectrofluorimeter, FTIR, spin coating, chromatographic techniques. Her national and international publications are very vast, focusing on quantum dots, organometallic complexes, photosensitization of colloidal nanoparticles. She worked on synthesis of quantum dots, protein binding studies, synthesis of silver nanoclusters, synthesis of coordination compounds. Currently, she is working as assistant professor in the Department of Chemistry, Sri GVG Visalakshi College for Women, Udumalpet. With this introduction, I now hand over the session to the speaker, Dr. E. Vaishnavi. Ma'am, please.
Good evening to all. Thank you for your nice introduction, Divya. I am very happy to present in this summer fellowship program conducted by Department of Chemistry, B.S. Abdul Rahman Institute of Science and Technology. At this juncture, I wish to congratulate the Department of Chemistry and HOD sir and the Dean ma'am and the coordinator of the program, Dr. Wasim Malai, for the successful completion of 8 days of virtual summer internship for master students. So today I am going to present on the topic the basics of nanochemistry and cadmium telluride quantum dots in sensor applications. So Divya, can I share?
Yes, Vaishnavi, you can share.
Okay.
Yes,
Then
your
my
full
slide.
screen mode. Yeah, it is visible,
1 second.
but not in full screen mode.
Okay. Is it?
Slideshow, go for slideshow.
Yes, I given the slideshow.
Or otherwise, bottom, you know, yeah, click that one. If not, stop sharing, do one more time.
Wait, no,
Stop sharing.
wait, I will.
Yes.
Can you able to see my screen, students?
Yes, we can.
Okay, thank you. So today I'm going to present on the topic the basics of nanochemistry and cadmium telluride quantum dots in sensor application. So start with Guru is like Brahma, Vishnu, and Shiva, who creates, sustains knowledge, and destroys the weed of ignorance. I salute such a guru. Without these gurus, I am not in such a good position where I am now. So they are all my chemistry teachers who I inspired in my life to become a teacher now. So I'm very happy to share you with you one moment. This is Professor T. Pradeep, IIT from IIT Madras. Hope you are all aware of that. I am also been a summer fellowship student in IIT Madras from in my MSc first year. So this man gave me an inspiration to synthesize the nanoparticles and silver clusters. After the inspiration made me a chemist, a nanochemist for synthesizing materials today. So with this, I will continue my topic, and this is about my my profile, what Divya is sharing to you. So today I'm going to give the outline of what is nanochemistry and what are all the types of nanostructures and the overview of quantum dots and the cadmium telluride quantum dots for sensor application and some research opportunity for master students. So we are moving on to the introduction to nanochemistry. So students, hope you are all did 8 days program. So you were somewhere else. Have you crossed this person? Have you seen this picture anywhere in your? Sorry. Students, can you hear me? I'm audible.
Yes, Vaishnavi, you are audible.
Okay. So I didn't get any response. No problem. So he is Richard Feynman, a Nobel laureate in physics. He's a man who is emphasized there is a plenty of room at the bottom, and the in annual meet of American Physical Society at December 29 it was conducted, and he gave the talk. The talk is given here. The what he is given in that days in 1959 itself. So he first give the word nano. This was first coined in 1960s later, and not only in 1916. In fact, in the nanomaterials or building blocks of this nanotechnology, it was used in the Roman glass in 2000 year ago. So hope you have seen these glasses. It is in daylight. It will be in it is a green color. When it is illuminated with light, it will be turned to a red color. So this is what Romans used in glass painting. So not only in 1960, before that also the nanoparticles are there in nature also. You can see the butterfly nature's creation, where small patterns of the material colors are in the small miniature structure. So nature is being one of a example that we are seeing daily. So how the arrangement of sunflower seeds we can see, how symmetrical arrangements we can see. See, the nano is already available in all natural materials also. So how big is nano? Hope anyone can tell me what is nano.
For Vaishnavi information, so we are not allowing the participant to unmute mic by themselves. Only
Okay.
during the question session we allowed because it is
Okay, then it
disturbing
is
us.
okay. Sorry.
Yeah, no issue. Thank.
Okay. The smallest object that we can see in our eyes is about zero point 0.1 to zero point 0.2 millimeter, which is 1 lakh to 2 lakh nanometer. So in metric, we can say that 10 to the power of minus 9, that is nano. So these tables which I given here, we have been studied in our kindergarten as well as in schoolings. You hope you are all aware of this table: micro, nano, femto, pico, milli, centi, deci. So these everybody we have crossed these metrics. So we are concentrating on the material 10 to the power of minus 9. So that is 1 nanometer will be 10 to the power of minus 9 meter. That is billionth of a meter. The nano, the word which means a druff, and it will be 1 by 80,000 diameter of a human hair. So hope I am clear with the nanometer size. To make you all more clear, I will give few examples. Actually, I really want to thank the slide shares for providing these slides. An excellent slide. So nano, that is 10 to the power of minus 9. That is our cholesterol molecule is 10 to the power of minus 9 meter. And the micro, our red blood cell. And the millimeter is the size of a bean. And centi is a bicycle. And kilo is a the distance that we use for measuring the distance, kilo. So mega, a big thing, a giga, it is like a big sun. Or this prefix for SI units is very clearly explain how big is nanometer. So to make it you more clear, I will let you know. I will ask the students to read this sentence. In the time it takes to read this sentence, your fingernails will have grown approximately 1 nanometer. Yes, can you believe that? If your fingernail approximately will grow around 1 nanometer. So this is the simple example. The students can exactly understand what is nanometer. So basically the definition of nanoscience is go with this definitions. The nanomaterials have an intermediate size ranging from 1 to 100 nanometer, between the atom and the bulk material. These nanoscience is a study of phenomena and manipulation of materials at atomic and molecular scales. So this is the definition for nanoscience. And nanotechnology means science, technology which utilize this nanomaterial for designing, characterization, production, and application of the structure devices. So this is the definition for nanotechnology. And it is an interdisciplinary science. As you all know that nanoscience and nanotechnology course can be it is like an umbrella of science, where a chemist, a biologist, a physicist, an engineering person, and a material science person, and IT person, and medicine as well as biotechnologists can implement their application in nanoscience and nanotechnology. Hence it is called as an umbrella of science. So this is the simple example explaining the materials property. So hope you all you can see here the two picture. One is rock, one is sand. One is rock and another one is sand. So the size matters in nano. So what happens when a material go to a nano science? See, for a construction purpose in general, we use sands. We nowadays now we are using more cement and grained materials only can fill more gaps, and it can only occupies more surface area. So this is a simple example showing a smaller object has more surface to volume ratio compared to that of a big rock. So big rock can occupy only one few surface, but this sands can occupy more surface. This is what I want to mean. The material property depends on its particle size. This has to be your take home message. So this is a simple example. Both are made up of polystyrene material, where a lid, a coffee lid, and a thermocol are shown here. This coffee lid and thermocol balls are made up of same material. When you dissolve in acetone, what happen means this thermocol balls behave differently compared to that of a lid, because this particle size when changes, the property of a material is also changed. So the weight of the thermocol is also changed. Can you able to imagine what I'm saying? So this is the implementation. The uniqueness of this nanoscale material only is because of its size. So when we go to the quantum size, what happens is it results in a good mechanical, electronic, photonic, and magnetic property compared to that of bulk material. So simple example, we can say that gold is a simple example, where bulk gold is yellow in color, but the nano gold is red in color. The temperature that to record to melt the bulk gold is around about higher temperature is required. But in case of red gold, which is red nano gold, few temperature changes will make the molecules to be unstable. So this itself shows the property of the material varies when the size varies. So high volume, higher surface to volume ratio is more for nanoparticle. So the chemical formation, simply it's a carbon. It is used in coal and all. It is like in coal we use sorry, the coal is a bulk material. This similarly, this carbon, when it is used as for the preparation of graphene dots, graphene sheets, and tubes, fullerenes, the chemical formation will be more, and their application is more when compared to that of bulk material. So this is one of the example I'm showing by it's a another Kim's publisher showing the particle size and the shape when it is vary, and the color of the material. They shows unique properties. The color sees the color of the material varies. This is a one of the example I want to show you. Say then we are going to the types of nanostructures. So nanostructures structures varies from metallic nanoparticles to carbon nanomaterial, organic, inorganic material. Some unusual, some few other types of materials are also available. Some polymeric materials, quantum dots are all available. So I'm not going deeper inside because we are going to see about quantum dots synthesis part and all. So we are concentrating on cadmium telluride quantum dots. So this is one of the indium gallium dots showing the nanometer size with the of 20 nanometer and height of 9 nanometer. And in general, students, these nanomaterials are prepared by two approaches. One is top down and bottom up. You can easily able to memorize this. From top to down and bottom to up. So in general, these five methods, sputtering and chemical etching, these are physical methods which can be used for grading the material from bulk to that of nanometer. But in case of synthesis of nanomaterial from bottom to up, there are also some method, that is sol gel process, vapor deposition, atomic molecular condensation, and spray pyrolysis. These are all the techniques which covers a big hours to discuss. So just I want to show you, this is the top down and this is the bottom up approaches. After synthesizing, what we will do means we will purify and then we will go for characterization part. In this characterization part, we will first we will go for powder XRD analysis. The structure, phase, composition of and size and the size and the crystallinity of the material is ensured from powder XRD. And optical spectroscopy are used for studying the unusual electronic behavior of the materials in the nano size. And the IR spectroscopy is known as infrared spectroscopy. It is used to identify the functional group present in the nanoparticles. And this SEM is the compositional and the structural analysis of the material. Is we can gain the knowledge from SEM, scanning electron microscope. TEM is transmission electron microscope, which provide you a high resolution of the particle size, which we synthesized. And the EDAX, which is the energy dispersion studies, where we can able to confirm the composition and distribution of the nanoparticles through elemental imaging. So XPS is also a study which will be in UG level, in PG level, this first 6 is okay, and XPS is also necessary for characterizing the X-phase photon spectroscopy to know the electrons behavior in the nanomaterials. So these are the applications of nanomaterials. It covers a wide range of applications ranging from food industries to energy industry. So everyone nowadays, you can see in advertisements, you can see more nano fibers, nano toothpaste, nano what all are nano. So you can see more applications of nanoparticles. So now we are going to now I have completed what is nanoparticle and how I can synthesize that particle and how I can characterize that particle. Now I am going to the overview of quantum dot. So what are quantum dots? They are the zero-dimensional material. Zero-dimensional means in all three dimensions, the material will be in the nano level. Okay, so it zero dimension means it has all three directionless behavior it will have. Okay, ma. So then quantum dots are the small particle. They are electrons are confined in a unit point space. They have only typical size ranging from 1 to 10 nanometer only. See, 1 nanometer can occupy only 8 atoms. See, these quantum dots can occupy 1 to 10 nanometer. In general, semiconductor quantum dots are more preferentially occurs from group 2b and 6a elements. So these materials are widely applicable in photovoltaic device, biosensors, imaging, light emitting diodes, and photo detectors, etc. Hope I am clear with quantum dots. What are quantum dots? So sorry, going to the history, these quantum dots were first discovered by Russian physicist Alexei Ekimov in glass matrix in 1986. And the word quantum dot was coined by Mark Reed. And the colloidal solution quantum dot was synthesized by Louis Bress. And this is one of the colloidal quantum dot synthesis by our UG student in our college, and she is now in a PG second year student in another college in Coimbatore, and she can able to efficiently synthesize nanomaterial quantum dots in our laboratory. So this is the synthesized quantum dots. Here the particle size, when we increase the particle size, it shows absorption optical property varies. So I will let you know clear in further slides. So this quantum confinement make this quantum dots more applicable material, because this all three dimensional, see here it is a bulk. In general semiconductors we have valence band and the conduction band. These we have a bulk materials, we have more surface. When you go, sorry, when you go for a quantum well, so they have a what to say, the it start breaking. Okay, when we have go for an one dimensional met, it goes further breaking. What happen if we go for a quantum dot? See, this is the quantum dots where x, y, and z in three dimension, all it is it is in a nano size. So it means the energy gap will starts breaking. So it have discrete energy levels. So because of its discrete energy level, one line become like a band gap, so it have more band gap energy. So then there will be more electron transition. So this electron transition will leads to a good optical behavior compared to that of other materials. So in general these materials exhibit a emission nature because of its electron hole pair recombination. So see here, valence band, it contains hole. When an incident light passed on the hole, the electrons jump from the lower level and it moved to the conduction band. From conduction band, when it gives back to the get back into the sorry, recombinations take place. A combination of this electron and hole pair take place, means we will get light, visible light. So this is the recombination of electron and hole pairs. So in general, the quantum dot has to be capped with suitable capping agents in order to avoid some non-radiative transition. See here in recombination process, some radiationless transition is occurring. So in order to avoid that, we have to put capping ligands. So the growth kinetic of the material is to be controlled. That's why the capping ligand are ordered into the reactions. So this prevent the aggregation and steric hindrance of the molecules to meet and to grow. So this prevent the tissue of the cadmium tissue from from exposure to cadmium. So this has a tunable optical and electronic property. This make this molecule more feasible for many applications. So in general, many 10 decades before, what happened is we are all using the organic dyes for many applications, but they have some disadvantages where they excitation only by specific wavelength only, but quantum dot excited by wide range of wavelength. And the organic dyes have narrow excitation and broad emission. It is in case of quantum dots, we have broad excitation and narrow emission. In the case of organic dyes, the lifetime will be lifetime of an organic fluorophore will be 1 to 10 nanosecond. Lifetime means the molecule which will stay in the excited state. That is the lifetime definition. So in photochemistry, you might be seeing that small definitions and all. So long fluorescent lifetime is available for quantum dots, and going for the stability, organic dye has less photostability, but these quantum dots are good stable than Alexa 488. So for the past half an hour, I am myself speaking. So I am give you a break to see a video for this.
Good day, everybody, and welcome to the Quantum Dot Multiplex Theater.
Whether the video is
I'm
coming,
going to tell you about our
students?
exciting future
Yes.
Okay. Can
Audio,
you
video, both are coming.
it is audible?
to grow up.
Yes, Vaishnavi, audible.
So it's a quantum dot theater. See, you can see this movie. Thanks for the animator.
Solar power cells, and a lot of us are even getting into healthcare these days. Now that sounds interesting. I'd like to help people be healthy. How can I do that? Well, let me see if I can make it easy for you. We're nano-sized particles that have very special, downright surprising characteristics at our small size. How big is nano? Well, we can't be seen with the naked eye, or even with the kind of microscope that you have in your school science lab. Let's see. I'm about 7.2 nanometers wide, and if you lined up about 3 million red quantum dots like me, side by side, they would be about the width of a human thumb, or about 1 inch. Wow, that's really tiny. What are we made of? Quantum dots can be made of various elements, but our tiniest building blocks, our atoms, are arranged in crystal formation. That means they're put together in organized, repeating, geometric three-dimensional patterns. And we're semiconductors. Great, I'd love to drive a train. Well, no, what that means is that we're excitable. And when we get excited, we emit energy, which can make us glow. So that's why I glow sometimes. Well, why are you red and I'm blue? Think of it this way. A semiconductor is in a little box. And if it's squeezed down even more inside that little space, its energy changes. As for quantum dots, depending on our size, we can give off light energy in a full range of fashion colors. Maybe watching this movie will help. Wow, quantum dots really are cool. I certainly think so, and so do healthcare researchers. So how can I help people feel better? In a lot of ways. You see, we're very clever. For example, we can play James Bond here in the nano world by attaching us to certain biological tracking devices like antibodies. Researchers essentially program us to find specific cells that are sick. You mean like cancer cells? Yes, that's right. And when they use different colored quantum dots at the same time and program them to attach to different things they want to observe, researchers can see how molecules interact inside cells. And then they know more about biological processes inside the body. This multicolored technique is called multiplexing. That certainly is clever. But how do we get inside cells? Depending on what they want us to do, researchers give us a special shell or coating that works like a molecular key to get us inside cells where we can do good things. We can deliver drug treatments and genes, and this is the really cool part. When we're built to work in sick cells, we can treat them without hurting any of the healthy cells. Just watch this.
So here quantum dot is doing the James Bond work. It's killing a cancer cell by means of its imaging application. So now the disease is cured by means of our quantum dots, and the cells feel very cool. So this is the end of the quantum dot theater. So hope you all liked this video. So this is a movie of quantum dot which I discussed now. Hope you all clear about this. Is the video was fully can you able to see the video, Anna?
Which one now? It is organic dye and quantum dot PPT.
Okay. The video is completed. So
Yes.
next we will move for next. Sorry, I got a problem. Okay. So now we are going for synthesize part. This is what this is what matter. The cadmium chloride is one of the precursor, or and next one is oxygen free sodium hydrogen telluride. That is for here we are using mercaptopropionic acid as a capping ligand. This reaction is carried out at the pH of 8.5 to 9, and it was complete solution is taken in a 3-neck RB provided with a stirring and hot plate mandel. Hope you all are aware of this apparatus. And the one neck is closed with an argon atmosphere, any inert gas atmosphere, and the another part is fitted with a output from where we have to take the solution. And next one is thermocouple is introduced in order to trace the reactions. So when the reaction starts, what happened is the cadmium chloride and sodium hydrogen telluride, which is preferred from tellurium powder and sodium borohydrate, this is got from another reaction. It will be a violet color solution. This cadmium chloride has to be weighed, and it has to be transferred in a 3-neck RB, and a few measurements are there, and we have to stick on to the procedure. And the Peng et al. Had clearly explained in the Journal of Luminescence related regarding this synthesis part. So we will follow the same procedure with some modification in the ligands. This is what we will follow. And these materials, what happened is the cadmium, it is it is suggested that the sulfur atoms in the thiol, emercaptopropionic acid, will go on stick on into the metal atoms, and the other polar group in the presence at the surface will make the molecule water soluble. Okay, so before that, many inorganic semiconductors was studied, that which gives you an organic soluble quantum dots. The water soluble quantum dots are very useful. The toxicity of the cadmium is minimized because of the capping ligands. So the toxicity of the material has to be in nanotoxicity has to also to be considered before utilizing into your biological applications. So this is how we will prepare. After that, we have to characterize. So first we have to go with the absorbance study. So this graph, blue color, can you able to see this? This blue color indicate the optical spectrum of synthesized cadmium telluride quantum dots, and this is the emissions of fluorescence study. From study we will get an emission around 580 nanometer, and after that we will confirm the synthesize procedure. We will put it into the UV chamber where we will glow the UV light. If it a particle is grown, we will get a various color as I saw in the early figure picture which we have discussed early. And then final is the TEM. See, this is the TEM image of the synthesized nanomaterial. The selected area electron diffraction study is SAED pattern showing a ring spots. These rings indicate the corresponding 111 and 220 and 3. I couldn't able to see the 311 plane of the cadmium telluride phase. Uh, so this video I have completely given on Professor completely synthesizing part. We can see this video later. So at the end of the session, if time permits, we will let I will play this video. So after that, sorry for the disturbance. Better I will put my mobile in mute. So now we are going to see the application of the synthesized above mentioned quantum dots for sensor application. So in general, sensors are devices that record and convert the physical or chemical or biological changes in a measurable signal. So simply we can say example for sensor is we are sensing the glucose level using glucometer is a simple sensor. Chip-based sensors are now available. And this receptor is a recognizing element which has to be recognized, and transducer what it do is separate the physical and chemical sense of the component, and the detector will do the sensitively determined the transduction method. Example, absorbance, fluorescence, conductivity, even chromatography, gas chromatography can be used to sense the analyte. So these are all transduction we can for the detectors we can use. So next one is the why we use spectrophlorimetry technique for sensing purpose. In general, analytical methods have been proposed by means of electrochemical and chromatography methods and all. But these the traditional methods gives you a more expense. This spectrophlorimetrically determined sensors will give you the extraordinary sensitivity and selectivity, and it is more convenient to see some adding the solution and measuring the sensor what is the optical behavior changes. We can able to track the analytes behavior. But in case of electrochemical technique, it is very accurate only. But compared to that, this is more convenient. So these quantum dots are used as an optical probe, that is light probing material. Many researchers tell that FRET analysis can be implemented for this for using these quantum dots for reduction sensors, chemical sensors, nucleic acids and proteins, urea and other drugs, or can be used. And in our studies, we used the sensor applications. So vitamin B12 sensor, this is one among the publications. From in this publication, we have synthesized cadmium telluride quantum dots with the mercaptosuccinic acid. We have just modified the ligand only, the capping agent. After synthesizing the material, we will do the particle size calculation from theoretical part. See, this is the quantum dots uptight, which is in the UV chamber, which is has large molar extinction coefficient. It has a high quantum yield, and it has a tunable color from. It is like a red color material you can able to see, which about it has a 10 nanometer size, and its concentration is 2 into 10 to the power of minus 7 molar. Okay, so after that we will doing the fluorescence quenching studies, where we will take the cadmium telluride coupled with mercaptosuccinic acid. Here we have added the methylcobalamin. We have indicated this methylcobalamin. So it's methylcobalamin, the fluorescence quenching take place. Similar experiments we have done with hydroxycobalamin and cyanocobalamin in order to compare with that. After comparing, we feel that this we can apply this to the sensing the analytes in the injection and tablets, so that we have collected some vitamin B12 injections and tablets from commercially available. So uh, before going to the procedure, we will take some 10 tablets and weighing the tablets, and we will crush to a fine powder in a mortar, and 550 mg was taken, and it is washed with ethanol, and it is used the super stock solution we will be preparing. Similarly, for injection solution also, we will make the concentrated solution. From the stock solution, we will make a experiment. We will compare our studies with that of the present in that of injection and the tablet. So the calibration curve we will get. So the unknown concentration we can able to deduct from the assay. So the linear limit from the linear graph, we can able to deduct the limit of deduction we can calculate. So all is formulas is basically come from the our analytical part only. The basic analytic chemistry what we go through in our Gopalan's book, the all formulas we can able to utilize for application levels, and the vitamin B12 and injections and tablets we are comparing. After comparing, we have to note down the interference concentration also we have to study. So for that, in the presence of nickel, in this copper, silver, and magnesium and sodium, cysteine and leucine, everything we have studied, and we found that copper and silver has more interference in this quantum dots and vitamin B12 interactions. And this generally, this material silver and copper can be removed by using cotton plug in the synthesis part. So we are doing some experiment for the interference of the far east. Was the work done, and our work quantum dots could able to sense about a deduction limit of 1 into 10 to the power of minus 7. This is comparatively, it covers a range from 1 into 10 to the power of minus 7 to 1.8 into 10 to the power of minus 6 molar concentration compared to that of the earlier work. So this is another work. Turn on, that is that work is about turn off sensor. This is turn on off on fluorescence switching off quantum dots and cationic porphyrin. Here we could able to come up with the coupling of quantum dots and cationic porphyrin nanohybrid, and for this we used as a sensor for detecting DNA. As you all well know that genetic information is carried by DNA, and it's the basis of gene expression, and it shows a significant function in our human life. So determining the concentration of DNA by means of simple and sensitive method is required, and it is need of the hour. So the qualitative and quantitative analysis of DNA has to be reviewed extensively. So here we tried out with the coupling this quantum dots and porphyrin. So porphyrin, as you all know, is a macromolecule structure with there are metalloporphyrins are also available. We are going to decorate these metalloporphyrin molecules with quantum dots. We do the solution, we play games with the solutions, and we develop as we can able to use this for a biosensor applications also. So these are the materials which we have used this for work, and this is the synthesized methods. And here thioglycolic acid capped cadmium telluride quantum dot was prepared. So here I have covered mercaptopropionic acid capped cadmium telluride, and here mercaptosuccinic acid capped cadmium telluride. This is thioglycolic acid capped cadmium telluride quantum dots. So various ligands we are changing for implementing their efficiency. We can also try. So this is an as usual procedure. So you can able to see the absorption of 4-hour sample, 6-hour and 8-hour sample, which is shifting towards red region, and the fluorescence emission is also recorded, and a EDAX image was taken, and CAS shows the elemental composition of cadmium and tellurium present in the solution, and the powder XRD pattern showing the presence of the cadmium telluride. So then next we have to finalize the particle size of the synthesized material, and we could able to scan the image till 20 nanometer scale bar. Here it is shown. It is 5 nanometer HRTM images was taken, and it was shown that vertical size was 3.9 nanometer, and the above a powder XRD we could able to conclude with result that this is a zinc blende crystalline structure, and we have to first optimize the condition for the reaction. So effect of pH we have studied, and effect of quantum dots concentration first we have studied, and effect of time concentration reaction timing we have tracked out, and we have finalized that 15 minutes the reaction fluorescent intensity was there, the reaction was completed. This is the fluorescence quenching study. This is the cadmium telluride quantum dots capped with the thioglycolic acid. When we add the cationic porphyrin, what happened is the fluorescent intensity decreased. Similar studies was carried out in the same concentration of quantum dot, but by varying the metalloated porphyrin. So we could able to vary the metalloated porphyrin, zinc and manganese. So binding constant between the porphyrin and the quantum dots was carried out, showing the TMPYP, that is tetramethylpyridyl porphyrin, has a binding constant of about 4.54 into 10 to the power of 5 molar. Because it is metal free, it starts binding with that quantum dot very well. So we are studying, did the same experiment in the presence of NaCl. So what happened in the presence of NaCl, we could able to observe the Stenwarmer plot was calculated by plot of I naught by I versus the concentration of the quencher. Similarly, in the metallated porphyrin also we have done. So from this we can able to we can able to realize that when I increase the ionic strength, when I increase the concentration of the NaCl, the quenching efficiency is reduced. It means the quantum dots and the cationic porphyrin is binding only because of its electrostatic interactions. This was concluded from this study, and after that we have to track the recoveries of fluorescence. So after quenching, we are adding the cough-thymus DNA, the DNA of cough in a concentration which is stipulated, we have already discussed in the material part. So after the addition of the DNA, what happens is the fluorescence intensity starts recovering. from this we have suggested that the quantum, see, the first one, A is the quantum dots, and B is the after adding porphyrin, and C is the recovery of the quantum dots fluorescence efficiency. From this we could able to conclude that the quantum dot can be an efficient material. When it is hybridized with porphyrin, it can able to determine the concentration of DNA. So this is what the study. So we have to suggest some mechanism. So for that, two possible mechanism is there. One is electron, or another one is energy. So here what we do is absorbance of porphyrin and the emission of the quantum dot was given here. So when, if there is no possible interaction according to Fred theory, we will follow the back literature back, we have to see. So there is no efficient overlap between the emission spectrum of the donor and the absorption spectrum of the acceptor means, then the conjure is not because due to energy transfer. So energy is not transferring here. It is an electron transfer reaction is taking place between the quantum dots and the porphyrin. So we will calculate the Reinfeldmer equation for thermodynamical feasibility of this reaction, and we could able to achieve a negative value for 3 porphyrin, which is given here. This shows this reaction is electron transfer process, which is thermodynamically feasible. And in order to compare why this cationic porphyrin or binding, or anionic or neutral porphyrin will bind, so we have changed the porphyrin also. So, but if we change the porphyrin, there is no change in the quantum dots fluorescent intensity we could able to observe in case of TPP, that is neutral porphyrin, and that is sub TCPP. So this from this we conclude this turn on of sensor is can only designed with the help of cationic porphyrin only. This is the basic solution study where we confirm this analysis using AFM analysis. First one is the cadmium telluride quantum dot showing 2 to 4 nanometer size of particle. In the presence of porphyrin, the particle size grown. After, what happened is, in the presence of thymus DNA, we could able to see the particle size was 2 to 5 nanometer. So this, from this results, we suggested that the porphyrin was peeled off from the quantum dot surface and the DNA starts binding. This is our assumption. Based on this, we have published this work on showing the schematic representation on sensor. So this was published, and this selectivity and sensitivity of the proposed method was also done. Selectivity means in the presence of thymus DNA only showing, or in other DNA also showing. We preferably found it is good for thymus DNA, and the interference study also made, and we have shown the interference of the other ions also. And we feel that our work is good compared to that of already found literature, and we could come up with a good reduction limit. So, summarize, this work was done by quantum dots and cationic porphyrin, and the electron transfer mechanism was confirmed, and the solution studies from we could able to come up with the reduction of DNA, and the and this is a possible approach for future research in designing high sensitive biosensors. This is a basic background studies for building blocks. We can take this studies. So still now there are many sensor based cadmium telluride quantum dots based sensors for mercury in water, and reduction of arsenic is under progress. And another one study I want to share it. In 2021, the determination of L-theanine in tea water was using fluorescence study was made using quantum dots, carbon dots, and nanoporphyrin with chemometrics. They have done the studies, and I'm also growing up in research, so I also tuned by all inspiring teachers. So still now I also studying on the literature part, reviewing the articles. So here also some 2021 there is a switch on fluorescent sensor of ascorbic acid was studied. Uh, so still the question is the cadmium telluride is toxic or not. Cadmium telluride is toxic, but more what to say, more concentration only, but in nano level some limitation is there. So in any nanomaterial we have to see about the usage of the materials. So apart from that, today graphene dots and carbon dots are being synthesized from carbon material, but I reviewed many articles for reviewing a chapter. I go through that the inorganic materials fluorescence is much better, but the toxic, in order to replace this toxicity, the carbon dots are growing up, blooming up today, and the graphene dots also. But all researchers are in this Summers Fellowship. So you all are the young growing researchers. You can do many researches on these kinds of dots for public applications. So this is the same. Now we have discussed on sensor applications. Apart from the sensor application, this cadmium telluride quantum dots are are applied in many fields. In photo, in biology and light emitting diode, etc. I have said that, and here is one ad which you have all gone this nowadays. Whether the video is coming?
Yes, Vaishnavi, video is
Yeah,
coming.
yeah.
View the world differently with up to 1 billion colors. Quantum dot display. This is Tiffany. Samsung.
So this is the application of 1 second. I think my system volume is very less. So this is the quantum dots application in TV. Q dot sensor, Q dot based TVs are available in Samsung nowadays, and this is organic light emitting diodes is now being replaced by quantum dots LED application, where we cannot now we cannot say about toxicity and all. Chips can use these sensors. More IPS screens are available nowadays, so we can able to use these quantum dots in applications. So this is about the research opportunity. I think I am on time. Shall I take 5 minutes?
Yes, Vaishnavi, you can
Oh,
take.
yeah. Thank you so much. So this is research opportunities for MSc students, where Tamil Nadu State Council provides some fellowship, some seminar come exhibition of the project. We can able to climb. The students can able to apply this Tamil Nadu State Council fellowship, and this is about JNCS CASR fellowship offered by JNCASR institution in Bangalore. So you all know that it is CNR Rao. He is the legendary person. Yeah, most valuable, no words to describe his contribution to the nanoscience. So we can able to apply, the students can apply the summer internship program in JNCSR, provided with you have to ask a permission from a mentor, and you have to apply this JNCSR research fellowship program for MSc students in their first year of PG degree. So this is about summer research fellowship programs, and this is available for faculties also. Now one of our department colleague is doing this summer research fellowship program in online also. So in IIT Delhi they are conducting in online. So JNCSR is usually some amount will be given for our project reports and all. So this will change our dimension from nano to macro. So our this is about Inspire Fellowship. I think you are all aware of this Inspire Scholarship for students. So this is what we have to take up one idea and bake that one idea in your life and think of it as dream of it. As Abdul Kalam said, we have to dream of it and live on that idea. Let the brain, muscle, nerves, and every part of the body be full of that idea and just leave every other idea alone. This is the way of success. This is the quote which I have taken in all work. I will follow this. So I encourage my young fellow children to follow this Swami Vivekananda's quote. And thank you. I think I'm on time.
Vaishnavi, thanks a lot. Yeah, thanks a lot for your kind acceptance of our invitation. Now the session is open for discussion. We have received several questions in YouTube as well as Zoom link chat box.
Okay.
Can I read, Vaishnavi?
Shall I stop my screen?
Yes, yes, you can stop it. No problem.
Okay. Thank you so much for giving me this opportunity. I wish to answer and I want to grow from kids' question. Uh, can you please give me the questions?
Okay. Yeah, I can read it now. So this
Okay.
question asked by Preeti Lahari from Center for Basic Science, Raipur, Chhattisgarh. Ma'am, can we synthesize quantum dots at our home using plant extract?
Quantum dots using plant extract.
Yeah, actually, the Vaishnavi began this question. I want to tell you one thing. For the major activities in this summer internship program, one is home mini project. So
Okay,
we
this
are
is
asking the students to do the mini project from their home with the available materials. So that
oh,
is why, with that intention only, this girl asked about this one. So is it possible to synthesize the quantum dots using plant leaves from our home?
okay. I hear that the carbon quantum dots can be synthesized from plant extract as well as the but we need the hydrothermal condition is has to be there in a proper condition has to be applied ma. I feel that carbon dioxide can be synthesized from plant extract, but you not only the plant extract, the what to say, cinnamon and pepper, all materials can be used. Because the carbon at zero dimensional is also showing the luminescence behavior, where we feel we couldn't till now. There is a question of how it fluorescence emission is occurring in that of carbon dot. I feel coming to the question, in home quantum dot synthesis is not possible. This is my opinion.
Yes, Vaishnavi, I am also agree with you. For quantum dots means carbon quantum dots you can prepare, as I mentioned earlier. The people they have prepared from microwave oven as well as dosa dawa. But in particularly, if you go for cadmium sulfide and cadmium selenide, these are a little toxic, so it is not advisable to use at our home. So
Yes.
you can go on that biocompatible quantum dots. Only things you have to do the literature survey. Based on the literature survey, you can get some idea and look the availability chemicals and other things at our home. Then you can start. Okay, Vaishnavi. The next question is from Nivedita. How does color depends on the size in a quantum dots?
Color depends on size.
Yeah, colors, well, you said VG or violet, indigo,
Yes,
blue,
yes,
red,
yes.
green, something. When we
Yes.
change the size of the particles, whether it would be affect the color or not? That
If
is
we
the question.
change the color of the particle, if we change the size of the particle, the color will be changed. This is due to the quantum confinement effect. If the band gap energy varies and the wavelength wavelength will vary. That if wavelength vary means the color is vary. Can you able to hope I am clear. From quantum confinement effect, we can able to conclude this question. The size dependent color is emitted by quantum dots.
Yes.
Okay.
And this question asked by Venkatesh.
Okay.
Uh, so the ligand, capping ligand we are using. What is the
Okay.
necessity to use the capping ligand, and what are the functionality groups should be there in that capping ligand?
Am I audible? I couldn't able to hear the question.
Yes.
Yeah.
Capping ligand we need to use for the
Yes.
nanoparticles. Am I correct?
Yes. Yes. Yes.
So that capping ligand, what is the necessity to use the capping ligand? That is one question. Second one, what are the functionality should be there in that capping ligand?
So, in general, the capping ligand is necessary for preparing a material. What happens is the ligand will what will do if an atom is come close together, the particle will start agglomerating. Then the particle will not be in the nanometer. In that case, the nanoparticle cannot be synthesized. If we use a capping ligand, means the capping ligand will prevent one atom to meet the another atom. So the distance between the atoms will increases. So what happened? This aggregation is prevented. So capping ligand is necessary, and mainly for depending upon the material what you synthesize. If you are synthesizing gold or silver, the ligand may varies. In general, sulfur containing ligands is taken for this quantum dot synthesis. In few silver extract, silver nanoparticle, green synthesis of silver nanoparticle, we use that plant extracts. In that, the plant itself reduce the silver, and it will reduction take place by means of the flavonoids and alkaloids presence in the extract solution. So it depends. So there it act as a surface ligand also. Hope I
Okay.
am
Yeah,
answered the.
yes. Yes, Vaishnavi. Can
Okay.
we go for next question?
Oh yes, no.
Reba from St. Benjamin College, that girl asked about what are the disadvantages of quantum dots?
The disadvantage of quantum dots means for cadmium tellurium, we can say it is cadmium is toxic. This is the one. The main disadvantage is all material has its own disadvantage. The nano toxic has to be studied before we use into our biological system. Even the silver nanoparticles will cause more toxicity when it is exposed more. I couldn't able to guess that silver it will turn the skin violet color. You people can tech savvy people can browse that. Usage of silver will leads to the toxic also. So it is toxic only. So next question, please.
Yes, Vaishnavi. And this question, Yatiraj College, uh, Shalika Mariam from Yatiraj College for Women. Ma'am,
Okay.
why does organic dyes having short fluorescence time when compared with the quantum dots? Quantum dots having long fluorescence time, but organic dyes are short fluorescence time. Why?
Organic dyes are made up of what to say, organic materials are made up of carbon, hydrogen and nitrogen, but in inorganic material we have the material metal. So the that metal makes the material more stable compared to that of organic material. So in simple example to say in OLED TV we purchase, it will work for a years. That what we are going for another part to be get more stability. We are going for quantum dots. So I feel that carbon, what to say, uh, the metal make the inorganic material make the quantum dot more stable compared to organic material. May I get the other questions? I hope it's my opinion.
Second one also we have to think there is a photo bleaching. If you're taking the organic dyes, there are more photo bleaching nature. But this one, when compared with that one, it is less one. Then second one, quantum confinement effect.
Yes, yes.
All are
This
correct.
missing in
Yeah.
carbon this material.
Yes, and this is a somewhat special question, I guess so. So Aishwarya Alex asked about the sensor. Ma'am, I want to apply for my quantum dots for sensor applications. How to improve the sensitivity, selectivity of my material? I mean, I want to use as a proof. So how to improve the sensitivity and selectivity of my proof?
How to improve? We can
Yeah.
think of combining with some other materials. We can simply, I have synthesized only cadmium telluride. In order to enhance the sensitivity, you can replace this core shell model, you can able to synthesize. And apart from this, nano composites also you can able to synthesize. I think this might be this can enhance your probe to be a good sensor for select to be stable, which enhance the sensitivity of your system. I suggest this.
Yes.
Oh.
Yeah, you are correct. Apart from that, you can use for other few things like you can go for antibody, antigen, more specific as well as
Antigen antibody.
yeah. Will give a more sensitivity and selectivity. So that
Yes,
technology
sir.
also people are
Yeah,
using,
yeah.
but it is very
Select.
expensive. You know, well, the pregnancy kit work, it is based on the enzyme, so it is highly.
So you can able to cap the
Even we
biological
can go
and
up to the commercial.
yes, yes, sir.
Yes.
The voice is breaking.
Yes, Vaishnavi. Can I go for next question?
Okay, 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 okay.
Venkada Mugila from Rajeshwari Vedachalam Government Arts College, Sengalpattu. Here I want to congratulate that Rajeshwari Venkadachalam Government Arts Sengalpattu students. They are asking several questions and all are valuable questions. Congratulations, students. And can you tell about the fluorescence quantum studies, madam?
Fluorescent quantum studies.
Quenching studies,
Okay.
fluorescence quenching.
Fluorescence quenching studies. Okay. So fluorescence quenching studies is that here we use fluorescent spectrophlorimeter for tracking our optical activity of the material. So fluorescence quenching studies, what we do is first we have to excite our molecule from when a light fall to our molecule, a molecule will get excited and then it will come back to its original state with the emission of light. This is what Jablonski diagrams explains about fluorescence. So in this fluorescence, even this oxygen is sometimes might be a quencher. Quencher means which quencher means what to say in the it will decrease. So oxygen we have to first remove from our solution and we have to do this experiment in an inert. So what we do is our sample is what we are going to probe. We are adding to this light emitting material. The intensity of the which emission intensity of the light will be decreased. This decreased is known, we are telling us quenching. From this decreasing, we will follow the fluorescence intensity decreasing is followed by means of spectrophlorimetric analysis. From there, The binding of the molecule and the of fluorescence is carried out is using binding constant study, and Stenvalmer, it is completely purely photochemical work. So this for fluorescence quenching is a study where fluorescence spectroscopy is utilized for tracking the light efficiency of the emitter. Hope I answered the question. May
Yes.
I get the another
Yeah.
question?
Yes. What is binding constant? This question asked by uh, Krishit from Tripura University.
So binding constant means what to say? Binding constant means the how your probe is binding with that of our quencher here. So that is calculated by K. Okay, so there are two methods for biological methods. We have another method. Benesi-Henderson equation is used for calculating. It is a theoretical calculation completely taken from our fluorescent I naught by I, that is intensity of the fluorophore and the intensity of the fluorophore in the presence of quencher. From that idea, we will able to calculate from the K values. So binding of the fluorophore and quenching. How come it is binded? That is what we are tracking.
Okay, this is the last question, Vaishnavi.
Okay.
Intuleka asked about, ma'am, we are using cadmium quantum dots, but with knowing or without knowing, if it is go inside of our body, what will be the toxicity? How we have to eliminate that cadmium from our body?
Cadmium, elimination of cadmium.
From our body. So without knowing or with knowing somewhat, there is a chance to go inside of our body. Am I correct?
Yes, of course. It
So
without or with knowingly we will consume it, because during our PhD studies, how many cadmium we have we have taken, I don't know. It's a very good question. I am finding the answer also.
okay, can I give a little idea about
Yeah,
this one?
please. Okay.
Actually, there is a limit, cadmium limit. So I don't know how much World Health Organization has been recommended the tolerance level of cadmium. May I know, Vaishnavi?
Will
Okay.
let you know now.
Yeah, maybe 2 milligrams,
Yes,
I guess.
please. Yes,
So less
yes,
than
yes.
that.
Yeah, yeah. I have mentioned the level of the material in my
Yeah.
paper. With that limit only we are taking for
Actually, yes,
our
I can give
studies.
answer.
Uh,
For example, if you want to prepare a cadmium quantum dots, we are not going to take a 1 kilogram of cadmium chloride, cadmium sulfide, only milligram, millimolar level, 1 millimolar level. If
that
you
is
calculate the
too.
1 millimolar level, it will come less than milligrams level, sub milligram level. Then that one we have to dilute it into the 100 ml water or 10 ml water. Then again it is diluted. From there we are going to take only for 1 ml or less than 1 ml. From that 1 ml only we will be preparing the cadmium sulfide, cadmium telluride nanoparticle. After that, the further purification process is there to remove the unreacted cadmium. There we will remove the unreacted cadmium. There are certain procedure which will
Yeah,
have been given by our Tamil Nadu Pollution Control Board. We cannot able to throw it in a sink. We have a separate container at our university everywhere there. So we have to throw it in that sink, and the Tamil Nadu Pollution Control Corporation people, they will come and collect and do the recycling process. So if you calculating all the things, whichever we have in our hand, that cadmium, it is less than sub milligram level only.
yes,
So
it is.
therefore, it is not that much toxic. And second one, anyhow, don't be lazy. Whenever you use the cadmium or lead, you have to use the gloves, and whichever the lab protocol is, procedure is there, we have to follow it. Am I correct, Vaishnavi? Do you want to
Yes,
give any
yeah,
further
yeah,
more
yeah.
comments?
Yeah, I agree with his statement. Exactly, we are using the material in the nanomolar level only, ma. So that will not give you much body inside the body and all. That I feel that we cannot imagine that much higher toxicity, and we will be limited toxicity only we will be using. So that too, the preventing ligand, the ligand will prevent the interference, penetration of the cadmium inside our body. So this is in the slide also I have mentioned that. So if this is the last question,
Yes,
really
yes.
congratulate the young research fellows who are in this summer research fellowship virtual program. I really congratulate the young minds for asking this much questions. It's nice. Thank you.
We have received more than 100 questions, but only selectively I have taken Vaishnavi.
Okay.
Okay. At this end, I have to thank our chief guest Vaishnavi for her kind acceptance of our invitation and deliver a very nice talk. And now I hand over the session to Divya. Divya, please deliver vote of thanks.
Yes, sir. Yes, sir. Gratitude is not in words, but it stays in the heart which express it. Ma'am, we admire the way you started the presentation by expressing your gratitude towards your chemistry teachers. And now it's time for ourselves to express our sincere gratitude to you. Our heart fills with lots of gratitude and respect for our distinguished guest for generously accepting our proposal and spending time for us in her busy schedule. I also thank you for spending your invaluable time to grace this occasion, but also for enlightening us with your talk. I thank you for clearing our concept and enhancing our understanding pertaining to the nanostructures, quantum dots, characterization techniques, and preparation and sensor application of quantum dots, and etc. Further, I express my humble thanks to Dean Dr. S. Kutirani ma'am and Dr. D. Ishwaramurthy, Head of the Department of Chemistry, and Dr. N. Vasimalai for their continuous encouragement and support throughout the program. I also thank you, ma'am, for delivering animated videos for quantum dots, which made the lecture much more interesting. Thank you, ma'am.
Thank you, Divya. And I have a video also. I will share the link to the program coordinator. And really, I would like to thank Vasimalayana for giving me this opportunity. I think I did my best. And I wish to all students a excellent career. Uh, to enrich your life, you have to keep on studying. All the best, students. Is there
So we
any
know
other?
each other for the past more than 15 years. Yeah, when she do PhD, I was a senior. At that time, I done my PhD at Gandhigram University. During the conference, we used to go for the research scholar. We used to go for the conference some places. That time we met together, and from there, she asked me several things, and also she has published very good articles, including analysts and big journals. From there onwards, I know her, and up to now, she's a very good friend for mine, and also a very good family friend. So thanks a lot for your valuable time and given a very nice talk. Thank you, Vaishnavi.
Thank you.
So
Thank you, students. Shall I leave or I have to be there for
yes, yes,
presentation?
Vaishnavi. If you want to see the participants seminar, you can stay here. Otherwise, you can leave. It's up to
Okay.
you.
I will stay
So
for one student. I want to
yes,
see.
yes, please. Yes.
Thank you.
Okay, dear participants, technical session is over. Now I can open the session for seminar. In between the gap, if possible, I can give a chance for our participant to give a seminar. Today, two persons are going to deliver their talk. The first person, Samir Rai, he's from Central University of Gujarat. And second one, Preeti, she's from Yatiraj College for Women's Chennai. So both of them going to give a talk. So now I request Samir Rai. Samir Rai, are you there?
Yes,
So
sir.
please share your screen.
Okay, sir. So can you see my screen?
Yes. Can you put it in a full screen view?
Yes, sir. So can you see it?
Yes, you carry on.
Okay, sir. Thank you, sir. Good evening to all the professors and students gathered over here. I would first like to thank Dr. N. Vasimalai sir for giving me this opportunity so that I can present over in this seminar. I am Sameer Rai from Central University of Gujarat. My participant's ID is MSO 167. And my today's seminar, I would be discussing and dealing about the nano medicine or the nano drug, which I have synthesized and I have given it a name, NanoDart. In this entire seminar, we would be dealing with the abstract of how the nanomedicine, what is the nanomedicine consist of, the introduction, the limitation of the existing system of, or the existing drug, and the benefits of innovation, then conclusion and acknowledgement. In the abstract part, we can say that zine is a hydrophobic molecule which can self-assemble itself into spherical nanoparticles and has been used in drug delivery for a long time. This innovation deals with the dissolution of blood clot and making the blood flow normal by the application of heparin. In this innovation, the heparin is encapsulated in the core shell nanostructure, which is made up of zine and alginate polysaccharide for the targeted drug delivery based on the change in pH of the blood during the thickening or clotting of the blood. Moving on to the introduction part, as we all know that since past 1 year, the world has seen an alarming increase in death due to COVID-19. The death due to thick blood, coagulated blood, and damaged blood cells, along with COVID-19, has complemented in the increase in mortality around the world. According to a report by WHO, the cardiovascular diseases are leading cause of the death estimated around 17.9 million deaths every year around the world. Through the formation of this drug, I have mainly emphasized on decreasing the death due to thick blood or the blood clots, which often gets accumulated in the different blood capillaries and sometimes also in heart and brain. I have given it the name NanoDart, in which you can see the nano means the particle in 1 to 100 nanometer range and dart means to break. The pH of the blood increases above 7.45 when the blood becomes thick. This condition is known as hypercoagulability, which is caused due to the excess clotting of proteins in the blood. This hypercoagulability can be diagnosed due to the symptoms such as dizziness, itching of skin, excessive menstrual bleeding, headache, gout, shortness of breath, and loss of energy. In the recent time, hypercoagulability is treated through antiplatelet therapy and anticoagulation therapy. In this innovation, I have encapsulated I have encapsulated heparin with the zine nanoparticle. The heparin, being an anticoagulant, dissolves in the blood and also reduces the thickness of the blood and hence decreases the basic nature of the blood, bringing to its normal pH. It is also used to treat heart attacks and angina. But application of heparin in such diseases has several side effects. The zine is a prolamine protein found in maize, which is soluble either in alkaline or the acidic medium. Thus, it can help in the targeted drug delivery of heparin at the specific site having the coagulated blood. Moving on to the synthesis part of the core shell nanostructure, or moving on to the synthesis of the drug, I would first like to tell that this synthesis part consists of two main parts, that is synthesis of core shell nanostructure and then the encapsulation of the heparin. In the synthesis of the core shell nanostructure, we can see that the production of zine nanocarriers involves a large variety of methods, including anti-solvent, electron spinning, electrospraying, supercritical anti-solvent, heat-induced self-assembly, and evaporation-induced self-assembly. All these methods involve the most common step in which zine is dissolved in the aqueous ethanol and then poured into hot water, forming the zine nanoparticle. It is then poured into the polysaccharide solution and is electrostatically adsorbed, forming the core shell nanostructure. In this synthesis of the nano drug, I have taken the polysaccharide as alginate. So the alginate is a polysaccharide which I used for the core shell nanostructure preparation because it induces the controlled release of the drug when the pH changes. Thus, when the pH of the blood will change, when the blood becomes thick, then only this drug will become effective. As you can see in the reaction present over here, that the zine, when reacts with hot water and aqueous ethanol, it forms the zine nanoparticle, which when reacts with alginate and electrostatic absorption, it gives the formation of zine alginate core shell nanoparticles. When we obtain these kind of nanoparticle, we have to see that the encapsulation for the heparin. So heparin is encapsulated by the double emulsification method. In the double emulsification method, the heparin is taken about 0.5 to 1 ml and mixed with low amount of water, which produces a heparin water emulsion. And simultaneously, the core shell nanostructures which we obtained earlier is mixed with ethyl acetate for about 2 to 3 ml. And then then the core shell nanostructure along with ethyl acetate forms an emulsion. Then both these emulsion are sonicated and 10 ml of PVP is added. After that, it is kept for stirring for 3 hours, and the ethyl acetate evaporates, producing the heparin encapsulated by the core shell nanostructures and forming our required or the desired drug. As you can see in this picture that I have depicted very clearly, the inner circle consists of water and heparin emulsion. The second circle consists of zine plus alginate and ethyl acetate, and the third circle consists of aqueous phase. This is a diagrammatic representation of how our encapsulated drug would look like. After that, moving on to the application part, this drug captures a wide range of application under its properties of dissolving thick blood. The design innovation of the nanoformulation of heparin will help to reduce the thickness of blood, which will help to reduce the thickness of blood and decrease the incidence of myocardial infarction or cardiac arrest and cardiac failure. This drug would be a boon for the soldiers serving in the extremely cold regions having temperature below 0 degrees Celsius. This drug would also help them to prevent myocardial infarction and keep their blood normal. Limitations of the existing system. In the present time, the doctors have been failing in curing polycythemia vera, so they recommend treatments just to improve the blood flow like phlebotomy. In severe complications such as organ damage, they prescribe chemotherapy medications like hydroxyurea and interferon alpha, which are capable of stopping the bone marrow from producing the red blood cells. Aspirin is a drug which comes under the antiplatelet therapy, which stops the action of platelets, preventing the coagulation of blood at the damaged sites. Warfarin is included in the anticoagulation therapy. The limitations may also include the problems such as bleeding problems. The bleeding is usually seen to come from the nose and gums. Moreover, the bleeding from cuts may take longer time to stop, and also it leads to heavier bleeding than the normal menstrual cycle. Next comes the bruising. The drugs such as aspirin may cause unexplained and unusual bruising under the skin, which may also grow in size. It leads to the formation of toxins in the blood. It is also a major symptom of leukemia. Next comes the alteration in stools and urine. The warfarin causes the alterations in the color of stools and urine. Hence, the color of stool changes to red or black, while the color of urine changes to pink or brown. This color change occurs due to the blood which comes out with the stools and urine. This drug may also cause piles or the gastrointestinal diseases and urinary tract infections. Next, coming to the interactions with the other medications. As we know that when we take drugs, it might get interacted with the other medications. The interaction of these drugs with other medications may lead to chemical changes in other medications and also in their own properties, thus causing the dysfunction in both their medications, which might be toxic and potentially harmful for the person. Also, it may cause purple toe syndrome, which is extremely uncommon and non-hemorrhagic complication associated with warfarin therapy. Moving on to the benefits of this innovation, I would like to describe that presently nanomedicines have found its way in every aspect of the treatment. It came up with the target specific drug delivery and has also increased the drug residing period. For conditions like thick blood, it is very necessary that drug remains in the blood for a long period of time, and also it should not affect other healthy cells. This design in nanoformulation will help to reduce the total dosage requirement and dosing frequency being targeted specific formulation. It will also reduce the interaction with other body tissues, and hence the side effect of this formulation is reduced. The key factors of innovation can be summarized as reduction in the total dosage volume. The reduction in this reduction in the total dosage volume decreases the cost of the drug. Reduction in the bleeding, the reduction in bleeding from nose and gums, and also the blood discharge in the menstrual cycle. Due to the coating of zine, the drug will dissolve only at a specific site where where the basic medium is high. Hence, the amount of drug involved in the treatment would be less. Prevention of the harmful interaction with the other medication, since the drug is only released at the sites where the medium is very basic, so it would prevent the harmful interaction which the drug could make with the other medications which we normally take. Prevention of bruising and alteration in stools and urine. The prevention of bruising may also not cause that the blood is released along with the urine and stools. Also, it would be easily available and administered because it is a nano drug, and it would be present. It would be means marketed in the capsules. It may also reduce the D dimer value. The D dimer value reflects the ongoing activation of hematostatic system. Its reference concentration is less than 0.5 mcg per ml or less than 250 nanogram per ml. The D-dimer value, as in the corona time, we have seen that people suffering from corona or having COVID, after they recover, their D-dimer value increases up to 3 or something like 4, 3 to 4, due to which they might get heart attacks or myocardial infarctions or something else. So this drug would help them to reduce their D-dimer value. Expected outcome of this nanodrug. The proposed innovation of the nanodrug delivery system is expected to improve the delivery of heparin to overcome the issue of thickening of the blood. As zine is natural protein, the developed nano formulation would be highly biodegradable and biocompatible. Being a natural anticoagulant, heparin-based formulation will overcome the issue of existing chemotherapy. These are the references I read for preparing the entire slides. And I would like to give a wholehearted thanks to Dr. Hitesh Kulhari sir, who was my guide, and he has supported in the synthesis of the social nanostructures. And thank you, sir. At last, I want to give one more thanks for your whole team, sir, for letting me give this presentation. Thank you a lot, sir.
Admit, please give a chance to the participants to unmute by themselves, those who are in Zoom. That provision you can give. The participants, you can post your question as well as you can unmute your mic and talk to Samir Rai. Those who are in Zoom link, you have a chance. Zoom link guys, you can ask question. Okay, so I have certain questions regarding about the fundamental things. The drug delivery, it is okay, but what about the drug loading capacity and drug releasing capacity of your material?
Sir, drug loading capacity.
Yes.
Sir, the drug loading capacity would be very low because we don't require a lot of amount of heparin. Sir, as we know that the drug loading capacity means the amount of drug present in the capsule. Sir, in the present time, the heparin or the means you might be knowing that Eliquis apixaban is used for curing the D-dimer value and reducing the this means the coagulated blood. So, sir, we can use this kind of drug because, sir, it is coated, so we don't require that much amount of drug. Very less amount of drug would be required, sir, because we are creating nanoparticles, sir. So the drug loading capacity would be very low.
Drug releasing capacity?
Sir, drug releasing capacity, the drug releasing capacity would be high because, sir, whenever the pH would be changing, whenever the pH of the blood will change, then only the drug will be released. So, sir, if in case we take a drug, right, like if we take the drug right now, and suppose after 2 days or 3 days we suffer from our blood starts clotting or blood starts getting thick, like hypercoagulability, then it will definitely release the drug, because it will remain in the body till then, because we have coated it with many things.
Okay. And for the participants' information, many people are interested to do the work in this area. I have much experience in this area. I learned the photochemotherapy. So generally, the cancer therapy it is based on the two mechanisms. We must know the difference between the cancer cells and the normal cells. Only two mechanisms. If you have a clear understanding about that one, then it is easy to make a drug delivery or any nanoparticles for their cancer therapy application. The number one, normal cell pH is 7.2, but cancer cells
Yes.
environment pH is 5. It is acidic pH. But cancer cells, it's a 5, normal cells 7. Then second one, the cancer cells will not be have a tolerance level up to 40. If more than 40-degree temperature, if we are giving 37 to 40-degree temperature, the cancer cells will be died. But our normal cells can have a capacity to be stable even though up to 45-degree, 45 to almost 47 something. So because of these two mechanisms only, all the medicines are going on. As Samir said, drug delivery. So even if you are keeping the environment pH is 7, drug will not release. Then the acidic pH it is there in the cancer cells. So therefore, we have to change the pH at acidic pH. That time drug will release because of the collapsions or fragmentation of nanoparticles. Then another one technology is called the photothermal therapy. So when you are passing the laser inside the plasmonic nanoparticles produce the heat, we have to optimize that heat. Then you can keep up to the 40-degree. Then particularly the cancer cells will die, normal cells will be alive. So these things it's there, and it is very leading technology. And today it is very essential technology also. You are the beginners. I know well these 1,500 students, many people wants to do their PhD. Please choose this type of area. Definitely it will be useful for you. Samir, for you, last question. Uh,
Yes, sir.
So then one student's participant, he asked about this question. This medication technology, is it very useful today, or is there any side effect?
No, sir. Actually, everything has a side effect. But the thing is, sir, this nanotechnology, or means whatever drug I have synthesized, sir, it is very useful, because, sir, in the present time, whatever drug we are using, sir, if there is a cut in body, then a lot of amount of blood will be lost. Even if there is a small cut, as I have already described in my presentation, sir, that there are a lot of limitations of the existing system, sir, like bleeding problems are there, bruisings are there, and also, sir, there is not a targeted drug delivery. But in my formulation, sir, the drug delivery is very much targeted, so it is the most beneficial thing. And also, sir, the nanomedicines are very much used because of their target specificity and chemical reactivity, sir. So definitely it has some side effect, but it is not as much as compared to the previous one or the existing one, sir.
Okay, thank you. And I have several questions, but because of the time limit, I can talk to you personally in some other times. You just think over about the receptors,
Okay, sir.
like a
Okay, sir.
folate
Thank you, sir.
receptor, many receptor. We can talk later about these things. Now I can give a
Okay, sir.
chance for Preeti. So Preeti, she is doing Preeti or Preeta?
It's Preeta, sir.
Yeah, sorry. Preeta, she
Okay.
is doing her master at the Department of Chemistry, Ethiraj Women's College, Chennai. Now I request her to deliver a talk.
Yes, sir.
Samir, you stop share screen, and Preeta, you can share your screen.
Is it
Yes, give
visible,
a full
sir?
screen view. Full screen view.
Okay.
Yes, you carry on.
My audio is clear, sir?
Yes, your audio is clear.
Okay. So, good evening, everyone. This is Preeta from Ethiraj College for Women in Chennai, Tamil Nadu. So, today my topic is LIBOR S squad in Sorry, sir, 1 second. There's some problem. Yeah, liber esquat inputor a mortuae. So this actually translates to the chemistry in putrefaction of dead. Putrefaction is nothing but decomposition of dead bodies. And I would like to begin with a quote by Anton Lavoisier. He said that I consider nature a vast chemical laboratory in which all kinds of composition and decompositions are formed. So this is a very interesting quote because it makes me think. When you talk about creation of life, it is very fascinating. At the same time, decomposition of body after death is also equally fascinating and makes one understand that human body is a very highly complex thermodynamically open system that is in constant interaction with the environment, even if the person is dead. So this is one point that I understood while doing a study on this topic. And my intention to choose this topic is to deliver the message. Today, I'll be covering various stages post-mortem, and I'll be explaining the chemistry behind it. So the first stage is pallor mortis. Pallor mortis translates to the paleness of death. So you must have heard people say that when a person is deceased after death, their body turns pale, that is white in color. Okay. So this is not something that I'm talking about a regional paleness, but the entire body turning pale is what I refer to here. Because when you see in Westerners, they don't have a lot of melanin content in their skin. When compared to people on the eastern side of the world, we have more melanin content and we have a darker complexion. So this paleness cannot be witnessed or cannot be seen distinctly in people in India or in regions that are onto the east. But in Westerners with lighter complexion, this paleness could be distinctly spotted because their skin color is usually pinkish or reddish, right? Because of the blood vessels that run beneath their skin, not just their skin, but in all human beings. The blood vessels that run beneath your skin is easily seen, visibly seen in their case because of the reduction in melanin content. And that's why they look pinkish or reddish in color. And when the person dies, blood circulation is going to be totally a collapse. So there won't be any kind of a blood circulation and the color is going to fade off and they will look pale in color. And that's the first stage of decomposition, and it's called as pallor mortis. This sets in 15 to 20 minutes after death. And the reason is the collapse of capillary circulation. The next most important stage is algor mortis. And algor mortis translates to the coldness of death. As the name suggests, it is talking about the temperature decrease. A person after death will show symptoms of decrease in temperature. And this could be understood when you think about all the reactions that are happening in your body that produce heat. For example, you talk about digestion, talk about burning of fats, burning of calories. All of this will give you energy to do work. And at the same time, it gives out energy in the form of heat. And that heat contributes to the body temperature. And when a person is not living, when there's no activity going on in the body, this reaction will not give the heat that contributes to the body temperature. So naturally, body temperature is going to decrease. And also another important reason is the circulation of blood pressure. So pressure drops and temperature also drops because they are directly related. Thus, there are these two reasons why the temperature of a person's body decreases. And this is an important tool that could be used to calculate the time of death using the Glaister equation. From this equation, the equation goes by 98.4 degree Fahrenheit minus internal body temperature divided by 1.5 gives you a value. And this value could be converted to the number of hours that has elapsed after death. And 1.5 is nothing but a calculated range or a calculated value, meaning to say that 1.5 degree Fahrenheit of temperature drops every single hour after death. And 98.4 degree Fahrenheit is the body temperature of a normal, healthy, living human being. So So this is one of the main applications. The third important stage, and this is a significant stage, I would say, this is called as livor mortis, and this translates to the blue color of death. Okay, the body turning blue is the fact that everyone knows. After death, body turns blue. But there's actually a problem in this. The entire body does not turn blue, like in the case of pallor mortis, where the entire body is pale. Here, only parts of your body turn blue. Parts of the body, in the sense, lower cavities or depressions in your body, is where this blue coloration is seen. For example, onto your left is a picture showing the dead body that is laying flat on a bench, and the lower part alone is blue in color. Okay, this is an interesting thing. I'll tell you why. In the previous slide, I told you circulation, capillary action is collapsed, right? So the RBCs are not moving or circulating in your body. Does that mean they are levitating in your body? No, they definitely will have to go and stagnate somewhere because they are not moving. They're immobile now. And I told you again that our body is an open system. Even though there are no forces from inside that are acting, there are external forces, and a main force is gravitational force. This gravitational force is acting on the RBCs that are present in your body, pulling them down to the cavities or pulling them down to where the body is made to rest, depressions basically. So that's where the RBCs come and settle down. And this is the part that you can see in the image. I'll tell you the reason for the blue color in the next slide. On to your right is another phenomenon that is called as blanching. So blanching is nothing but just a test. You can also do it if you are working as a post-mortem forensic toxicologist, where you can press your thumb or index finger onto the surface where this blue coloration has happened. And for a minute, you can see the impression of your finger on that surface, and that place alone will be pale. Meaning to say that you are pushing or you are putting external pressure, moving the RBCs away from that place for a minute or a second. And these are definitely going to come back again. And that proves that these are stagnating below the skin and are not in motion. Okay, so this is blanching. Now I'll tell you why it's blue in color. Okay, so this is another pictorial representation of lividity, that is blue coloredness of body, and blanching. Okay, why blue color? A very interesting question. I'm pretty sure everyone is wondering about it. First thing is, when you look at your wrist, you can see your veins running. And what color are they? They are blue in color, right? And all of us must have studied in biology that our veins carry deoxygenated blood, or it is collecting all of the waste in your body and it's going back to the lungs for exchange of gases. And the blood in your body, first of all, when a person dies, okay, at that minute, they may have inhaled some oxygen, meaning to say there's very little oxygen, which is going to diffuse into the blood, and you're going to have very little amount of oxyhemoglobin, that's red in color, running in the arteries. And after death, there is no exhalation of carbon dioxide. Carbon dioxide is going to stay inside, no oxygen coming in, no carbon dioxide going out. So the oxygen that is inside the body will be used up by cellular respiration that is momentarily going to stop. And now there's only carbon dioxide in your blood and there's no oxyhemoglobin at all. And when circulation stops, what will come and stagnate? Only deoxygenated blood is going to come and stagnate, right? Because there's no oxygenated blood at all. Okay, I think it's making sense. There's no oxygen intake at all. And the waste that has to be removed from your body, which is carbon dioxide, has not got any way of exit. And at the same time, decomposition is in progress. And what is the product of decomposition? Again, it's carbon dioxide. So carbon dioxide will keep building in your body with no means to escape. And that's going to keep binding with hemoglobin to form deoxyhemoglobin. And that is the blue color of the blood. And the stagnating blood will be blue in color, or bluish purple in color, to be more precise. And this is the reason why the body turns blue. And this blue does not stay for a long time. After a few hours, it's going to fade off. And that's because of a totally different phenomenon, which I'll be explaining again in my other slides. So the difference in color, just an extra information. So the difference in color of oxy and deoxyhemoglobin is because of various reasons. The first reason being, if you look at hemoglobin, it's a metalloprotein, and heme is a complex. When you look at the coordination chemistry of heme, in oxyhemoglobin, it's a low spin complex, and deoxyhemoglobin is a high spin complex because the sixth position is completely unoccupied in iron. So due to this difference, their absorption will vary. This oxyhemoglobin will absorb in the blue-green region, and deoxyhemoglobin will absorb in the orange region or red-green region. And that's the reason why they show different colors. And another reason is the hydrogen bonding. I hope the picture is visible. The right-hand side of the slide shows you a picture of oxyhemoglobin, where you can see the bond that is formed between oxygen and the oxygen and the hydrogen that's present in the imidazole part of the histidine residue. That also will shift absorption towards a longer wavelength, leading to red shift. That's why oxyhemoglobin is red. And this is another reason, the difference in conformers. So these are few of the reasons why oxy and deoxyhemoglobins show difference in color. And since no oxyhemoglobin is present, your body turns blue. I hope you understood. If you ask me any more doubts, I'll definitely explain in detail. The next stage is autolysis. Okay, this is the reason why the blue color fades. I hope you are interested in this topic because here again, I'm going to explain a basic concept. Okay, why do autolysis happen? Autolysis is nothing but the breakdown of cells. Again, going back to the same story of how carbon dioxide is building up in your body, this carbon dioxide is not gonna be inactive. It's going to go and react with all the water molecule that is present in your blood. Basically, water makes up 64% of our body. So it's almost everywhere. And carbon dioxide is going to go and react with water to give you carbonic acid. And carbonic acid is highly polar. So it's going to split up easily into protons and bicarbonate ions. So this proton that is released is going to be so many more times greater than imaginable. Okay, so this is actually a process that is happening in our body even when you are living. Okay, and when a person is dead, as I told you, decomposition also will add on to the total number of carbon dioxide present. So it's going to be more number of times that could be imagined by us. So this carbon dioxide will decrease the pH of blood. When pH of blood decreases, it's decreased so much that the cells start to rupture because the acidity will start creating or will start melting the cell wall, and the cells will rupture, releasing lysosomes and enzymes that will eat the cells up. This is called as autolysis. And the blue color starts fading when autolysis sets in because RBCs are also broken down. When RBCs are broken down, then there's no point in talking about hemoglobin and its color. So this is the reason why the blue color fades. So these are some phases of autolysis. You can see that there is a very drastic change from picture A to picture D because it's a very fast process and the enzymes will start eating up the cell and its organelles, leading to a complete destruction. Now moving on to Bohr effect. Bohr effect is very important for you to understand the exchange of gases. I'm not going into the detail, but I'll just tell you how pH plays a role in this. When pH is less, hemoglobin will have lower affinity to oxygen. So if you relate, lower affinity means hemoglobin is not going to bind with oxygen with preference. So it's going to release oxygen. And when pH is more, hemoglobin will have a preference to oxygen or higher affinity to oxygen. I'll tell you how in this picture. I'm sure you will understand by looking at the picture. Carbon dioxide is building in your cells because of cellular respiration. Okay. And this carbon dioxide is in high concentration within your cell. But outside the cell, in the bloodstream, in the plasma, carbon dioxide is less. Okay. Its concentration is very less. And now blood is coming in. Blood is coming from the lungs towards the cells, carrying oxygen. This is oxyhemoglobin. Okay. And this bloodstream is rich in oxygen, that is high concentration of oxygen. Now, simple diffusion happens. Diffusion is usually from higher concentration to lower concentration. So what oxygen does is, its concentration is less in the cells. So it will diffuse into the cell. And since oxygen is coming inside, carbon dioxide will have to exit. And its concentration is less in the bloodstream. So it will diffuse out of the cell into the bloodstream. And this is how hemoglobin, like transport facilities, will come, drop carbon dioxide, drop oxygen, pick carbon dioxide and go back to the lungs, and it is exhaled. So this is the reason why this is the reason why all of this is happening, the blue coloration, because carbon dioxide could not be efficiently given out. So the next one, again, this talks about the exercise. When you do a lot of physical exercise, people become breathless. They start panting. Why? Because when you are doing a physical exercise, your body needs oxygen and your body needs energy. So when energy is produced, carbon dioxide is also produced. Thus, the pH is going to get reduced and the need for oxygen is more when you are doing a physical exercise. And that's why you take in deep breaths of oxygen to compensate the change that has been caused by carbon dioxide. The fifth stage is rigor mortis, and rigor mortis nothing but is the stiffness of body, and this is caused by the muscle contraction. And muscle contraction is nothing but the cross bridges that globular proteins like actin and myosin form. So the breaking of these bonds require a lot of energy. That is not given by a person who is dead. No cell in a dead body will provide the energy for breaking of these bonds. So naturally, they are going to stay contracted. But again, when cells start degrading or even when the tissues start decomposing, this is going to relax. The bonds are going to break by natural forces, and there's going to be complete relaxation. This shows you how the bonding forms between myosin and actin and how they break. Now, ATP will come into play. ATP is the one that provides the energy to break the bond, like an SN2 intermediate step, where ATP here is going to come and form a bond first with myosin. And then it's going to make myosin dissolve the bond that it has formed with actin. Thereby, there is simultaneous formation and breaking of bond. But this cannot happen at all in a cadaver. And that's why rigor mortis sets in. The next stage is putrefaction. So this is where exactly people think decomposition happens, but the other stages are also decomposition only. So in putrefaction, as I told you in the earlier stages, it is caused by a lot of reasons, not just one, but the first reason being bacteria. Bacteria is the one that kickstarts putrefaction reaction. Here, carbohydrates, fats, and proteins that probably was in the verge of getting digested and the person died. So it's not digested. And fat deposits in your body. All of this are acted upon by bacteria. They degrade all of them, decompose them to produce three gases: carbon dioxide, hydrogen sulfide, and methane. These are the smelly gases that comes out of sewers, like from drainage. These are the gases that come out. And for your information, all these gases are produced even in living human beings, but are eventually released by your flatulence and also by the bad breath that comes out of your mouth when you take in a lot of sulfur containing compounds, like compounds in the sense food that contains a lot of sulfur containing compounds like onion, garlic, etc. So this is the reason why body smells very bad. Okay, this diagram, actually, I'm just going to tell you halitosis alone, the bad breath, because of methane thiol, which is nothing but mercaptanes, and then hydrogen sulfide, and then you have dimethyl sulfide. All are volatile sulfur containing compounds that are produced in your body, causing that very bad odor. So how sulfur, what is the source of sulfur? Again, another question that came to my mind. These are given by, or these are supplied by the proteins. There are some proteins which contain sulfur in their molecular formula, and these are few of those proteins that contain sulfur, and they are to a maximum limit present in egg, fish, and other protein containing food that we take in, and also even in onion and garlic. So they contribute to the sulfur that is taken in by your system, and they also lead to the formation of H2S gas in your body. That's why when you eat a lot of proteins, you have gastritis problem because of the formation of H2S and methane and also carbon dioxide that's formed. So the first sign of putrefaction, I'll just go fast. So this is the first sign, bloating. Bloating is nothing but, as I told you, these three gases that are formed in your body, they don't have any way to go out of the body, escape from the body, right? So they are going to inflate the body and make it resemble a balloon. So your body is just going to bloat up like a balloon. And eventually from inside, the gases are giving a lot of pressure and the skin cells rupture. Finally, the smell of death comes out. This is why body stinks. This is how your body turns, like a cadaver looks like after this stage is complete, which is nothing but bloating stage. Now the H2S is not going to be inactive. It's also equally active like carbon dioxide. It's going to go and react with hemoglobin that is still not decomposed and form sulfhemoglobin. Now, sulfhemoglobin not just binds in the site of oxygen, but also oxidizes Fe2 plus to Fe3 plus, giving a green pigmented molecule. And this is the reason why at later stage body turns green in color. So you can see the body turning green gradually, but this is not something that happens in all bodies, but depending on conditions, you can also notice green color, which usually looks like dark blue. Okay, it's a significant stage. Sulfhemoglobin is formed. And the next one, the last stage, is active and dry decay. Active and dry decay is initiated by natural forces. When the smell comes out of your body, it's going to attract a lot of agents like flies that come and lay eggs on the body, and they then give out larvae, which is nothing but maggots that will feed for nutrition on the decomposing body, and it speeds up the decomposition process. And since the skin has ruptured now, oxygen intake is happening. It's free to take in oxygen. So aerobic bacteria will combine with anaerobic bacteria to increase the rate of decomposition, and all the internal organ cells are degraded. Now, finally, what is left is bones, some dry skin and cartilage. In bone, calcium phosphate cannot be decomposed by microbial action, but it can react with acid that can probably be present in soil, like peaty soils will have a lot of acidic content, with which calcium phosphate can react and it will melt down the bones, or under force they can be crushed into ash. So the Capers law will help you understand the point that I am making you all clear with. The point that our body is in interaction.
Sorry for the disturbance. Please
Yes,
conclude the session within 2 minutes.
Yes, sir, definitely. Sorry, sir. Okay, so Capers law tells you that point which I'm trying to convey. In these three photos, you can see the first one being a body in water. So this body in water is floating because of the bloating process. You can see the body is bloated, and it will take 2 times longer to decompose in water when compared to a body in open air. And it takes 8 times longer to decompose in bodies that are confined in coffins. So last conclusion, I would like to say a few words about natural mummification. The action of environment not only results in decomposition, but can also act as a preventive measure to stop decomposition. The image onto your left shows a mummified, naturally preserved mummified body that was taken from and restored from a bog. Bogs usually contain humic acid from dead and decaying organic matter that resembles vinegar, and it will pickle the body. The image onto your right shows the mummified body of a small child, a kid, that was taken from the South Pole. So because of the temperature drop, this was prevented. The decomposition was prevented. This is a soap mummy that is formed when all the internal organs decompose and the body is full of fat, a fat layer, right? And this fat will undergo saponification in soils with suitable So adipose sheet is formed and the body is mummified. Sir, is that it? Hello?
Yes, you finish?
Yes, sir. Summary and sir,
Yeah,
my
yes.
slides are not moving. 1 second, sir.
You can tell by oral, no problem.
Yeah. So this is the summary. These are the 5 stages of post-mortem decomposition, and these I have already discussed just in a pictorial representation. These are few of the references that I have taken from the internet. And thank you all for listening to my seminar patiently. I hope I delivered my message. Thank you so much. I've taken so much time. Sorry, sir. I thank
No,
the
it's
organizers for giving this opportunity.
okay. Preeta, you have given very nice talk. Generally, it's just for fun. Our Indian ladies, they have a fear about the dead body, but you are bold lady. You just
Thank you, sir.
explain many things. But that type of interest, if we have it, then fear it's not a matter. Thank you for your excellent talk.
Thank
We
you,
have
sir.
received some questions in a chatting box. This question asked by Venkatesh. Generally, we used to put the dead body in ice. So, such a cases, if you put the dead body in ice, how to find the death time exactly?
So that is because when you put the cadaver in ice box, it's definitely going to prevent decomposition from happening. But there are some stages that will happen, sir. First reason is the paleness of death that I told you. The first stage is definitely going to happen even if it's present in ice, because circulation has been stopped by our body, not by any kind of an external interference. So it's going to stop circulation, and the first reason will happen, and the second reason is nothing but the decrease in body temperature, which could also be analyzed to an extent, because body temperature is lowered and it is going to lower to match the ambient temperature, that is the ice box temperature. So with that, you can calculate the number of hours that has elapsed after death. Is that it, sir?
Okay, it's not a religious question. Think like it is a general questions. I'm
Yes,
not
sir.
going inside of the.
Sir, you're not audible.
Generally, they are doing a firing or some, for example, tribals. They are putting the body in a forest. Some wild
Yes,
animals, other like big birds, they can come and eat it. So, based on
yes.
your point of view, so our intention to decompose the body without having any harmful to the environment as well as society. Which method is the best one?
Sir, I think nothing is harmful. First thing is that if you let a body decompose by natural forces, it's going to be a food. It's going to be like a food for some organism. Even microorganisms are being benefited in a great way. And also the flies that come and lays eggs, and the maggots eating and becoming flies. Again, it's like a biodiversity, sir. It's a cycle. So all of this is happening in a cycle, and if you burn a body, it's definitely going to contribute to environmental pollution. So that's wrong. You don't really have to burn a body. This is not something that I'm talking through religious practices, but
Yeah,
burning a
yeah, we
body
can
can
talk only
actually
science. Yes.
contribute to pollution. But if you bury a body, it's going to be definitely it's going to become manure for the soil. Then you can also do a lot of studies to know about the person who's dead, like dead who's archaeologists. So archaeologists actually dig up graves to study about civilizations. In that way, graves can be dug up and studied in future. So that way it's useful from my
Okay.
point of view, sir.
Yeah, yes, sir.
Totally.
And this is the last question. This question asked by our MSc, Crescent MSc students, Nivedita. Why mummification? Mummification has to be done. Is it necessary?
Not necessary. It is necessary in case of forensic studies where people can know more about embalming processes, how to stop decomposition. That's also a lot of chemistry involved in it. So you can actually study this and come to a understanding as to how your body reacts to chemicals. what kind of response it gives to embalming fluids. So that will give you more knowledge about chemical environment of your body. And another reason is you can study the person's internal organs, the cause of death. If the death was caused by taking in drugs or by some adulterants or by poisoning could be studied. And in ancient Egyptians period of time, this was done as a ritual because they believed in afterlife. And fourth most important thing is it helps you understand human anatomy, mummification.
Okay. Thanks, Preeti, for your excellent talk. And also, I have to thank
you, sir.
Samir Rai for your excellent talk. Dear participants, I'm sorry I just took a 15 minutes extra time because topic was very interesting. Hope you understand the situation. So tomorrow onwards, I will be try to finish the session at 6 o'clock. Thanks a lot for your kind attention. And your feedback link, our feedback link is posted in a chatting box of YouTube as well as Zoom links. All of you please delete it. It will be active for 30 minutes. Tomorrow session will be started exactly at 4 p.m. by tomorrow. Thank you so much. Admin, please post the feedback link and close the session after few minutes.
Yes, sir.